Honors Algebra 2 Pre-Calculus. We are in 9.6 in Pre-Calculus. So there's a formula on page 664 for permutations of n items. But before we jump to using that formula, I want to use our knowledge of the fundamental counting principle and some logic to figure this formula out. So how many ways could you arrange 2 items? Well, if we use that fundamental counting principle, think about it this way. I have 2 spaces for those items. Since I'm arranging the items, I can't repeat them. Like once I pick an item to put down, so I have 2 choices for the first spot, but then only 1 for the second spot, so I end up with 2 possible ways to arrange 2 items, right? If I were to have 3 items instead, well, now I have 3 spots because I'm going to place those 3 items out. For the first spot, I have 3 possible choices, but once I pick an item, I can't pick it again, so now I only have 2 choices, and then after I pick that item, I only have the 1 option left, so I have to put whatever's left in the spot, so 3 times 2 times 1, which is 6 ways, right? How about 4 items? Well, now I have 4 spots open, right? But I have any one of the 4 items for the first spot, so that's 4, but now I chose one of them, so I only have 3 items left that I could pick in the second spot. Once I pick one of those, I only have 2 items left, and at this point I've chosen all but the last item, so that I have to put that last item in the last spot, so I end up with 24 ways. It's not so much the numbers I want you to notice at the end, the 6, the 2, and the 24. What I want you to notice is what this operation is. 3 times 2 times 1 is an operation that we learned about in 9.1, right? Or not 9.1, sorry, maybe 9.1, I don't know. Anyway, one of these sections, we learned about factorials, right? So this, if we had n items, I would have n factorial ways to arrange them. So if you have n items and you want to arrange them where order matters, you do it in n factorial ways. And again, this is the logic, but as your numbers get larger, it's a lot easier to just see that it's a factorial. We'll talk about what happens when we have, so this is, let me add a little word after this. I'm going to say of n distinct items. And I'll talk to you about what I mean by distinct in a minute. Sort of the short answer about what I mean by distinct is that they can't be the same item. So for instance, if I wanted to arrange the letters M-O-M, 2 of those letters are the same. Also, happy belated Mother's Day to anybody that's a mom out there. But if I wanted to arrange M-O-M, M and M are the same, so unless I call one of them M sub 1 and M sub 2, which would make them different, it doesn't matter which of those 2 M's is in which spot. So it could be the first M, followed by the O, followed by the second M, or I could switch the 2 M's and you wouldn't notice. I could put the second M first, and then O, and then the last M, but you wouldn't notice because they were not distinct items. So we're going to talk about what happens when they're not distinct items later. So it matters that these items are in an order. It matters that these items are currently distinct, right? So for instance, MOM has 2 indistinct items, right? The M's are the same.